Okay, let's go ahead and get started with Introduction to Fractions. We are re-recording because apparently the sound didn't want to go through, so I'm going to just do this as if I were writing it for the first time. So, what we're going to talk about is we're going to talk a little bit about some notation with fractions, the difference between proper and improper fractions. We're going to definitely talk about some equivalent fractions, and we're going to talk about 1 and some equivalents of 1 that we're going to use. Well, the first thing to note about a fraction is it is basically pieces of a whole. So if I think I've got one entire whole thing, I can break that up into separate, equally sized pieces. Now, the count of the number of pieces there is called our numerator. And that's the count of how many pieces do I have. The denominator is, well, that basically says how many pieces make up one entire thing. The numerator is the top. It's the count of how many pieces we have, and the 4 is basically the size. How big are those? The bigger the number here for our denominator, the smaller the piece. So think about it this way. If this were $1, this would be $1/4. How many, if you think about how many cents go into $1, that would be 100. And actually the word cent means 100. Cent, like century, there's 100 years in a century, 100 centurions in a legion. That would be 100th. So, the bigger the number, the smaller the piece here, where this top just basically is how many of those pieces do you have. Another thing that you can think of when you're saying this is this, if I take a look at another one where I've got, say, 5 different pieces and I've got 3 of them, each piece here is 3/5, or what I've got colored here is 3/5 of the circle. And one of the things to note is that every time we have a fraction, we have a division problem. So that 3/5 is also, that's equal to 3 divided by 5. So you've seen this notation before. We did talk about that when we talked about doing some division questions. Alrighty. Let's move on to talking about proper fractions. And a proper fraction is a fraction where my numerator is bigger than my denominator. And when my numerator is bigger than my denominator, then I've got some fractions where, and by the way, that's numerator greater than denominator. It's things like 1/2 or 3/4 or 16/27. As long as my numerator is smaller than the denominator, as long as that top is smaller than the bottom, we have a proper fraction. And one thing to note with this is these are all just pieces of a whole. This is all portions of 1. Because it's always just a portion, because I don't have as many pieces as it needs to make up one entire whole. Every time we see a proper fraction, you should note that all of these fractions are going to be smaller than 1. They're going to be less than 1. Well, with a name like proper fraction, I hope it leads you to ask, is there something that's not proper? Well, yes. There are improper fractions. And an improper fraction is where your denominator is either bigger or the same size as your numerator. And I ran out of space here. So your denominator is larger than or equal to your numerator. So we would have fractions that look like this: 4/3, 2/1, or 5/5. And we have a couple things here where if I've got like 4/3, I've got more pieces than would make up an entire whole. So this thing would be 1 and a little bit. Here my pieces are just equal to an entire thing. Each piece is one whole thing. So this right here, this number would be equal to 2. And then I've got this special one here, 5 over 5. That one right there basically says, oh, I've got all of the pieces I need to make up 1. So each of these numbers are going to be equal to 1, or they're going to be bigger. Now, also, don't let the name improper fraction scare you. It's just a title. A lot of times improper fractions are easier to work with than our mixed numbers, which we will talk about later. Well, let's talk a little bit about equivalent fractions. And anytime we've got a fraction where we could change the form. So say we have 3/4 and we want it to be something that has a 20 in the denominator. Well, as long as I multiply the top and the bottom by the same number, I will have an equivalent fraction. So 3/4, if I multiply the top by 5 and the bottom by 5, I'll end up with 15/20. 3/4 is equivalent to 15/20. They would represent the same quantity. Or if you'd like to think of it in food terms, you've taken pizza slices and you've made the slices smaller. But it'll still fill up the same amount of box. Well, we can also do things like make these things smaller. So if I had something like 12/18, if we were to note that both 12 and 18 are both multiples of 6, I could say, hey, I could divide both of these numbers by 6. 12 divided by 6 would be 2. 18 divided by 6 would be 3. So 12/18 is equivalent to 2/3. We call this process simplifying or reducing. And we're going to be doing a lot more of this later on. In fact, the next video is going to be all about it. Okay, last but not least, we have 1. And, anytime we've got a fraction that is a number divided by itself, or a number over itself, that is going to be a number that is equivalent to 1. So it's like 6 over 6 is equal to 1. 13 over 13 is equal to 1. 5 over 5 is equal to 1. Even 7,287 over 7,287 is equal to 1. All we're doing when we have a fraction that looks like this is saying, well, we've got, with this 6 over 6, all I'm saying is I've got some whole where all of my pieces are equal to 1/6, and I have all of the pieces. It's just going to be equal to 1. That's going to be helpful for us later when we have to multiply by 1. And sometimes these are going to be what we will refer to as well-chosen ones. Okay? I will see you in the next video.